Okay, very quickly referring to page 389 of practice 10 now. There is a cylinder as well as a cone given. Alright, the whole volume is 60 cubic centimeter. Show in part 1, the formula is given as that. Cheryl, what must we do? Part 1. This whole volume is equal to 60, right? So you must form that equation and make H the subject. What is the formula for volume of a cylinder? Pi r square H. Volume for this cone? Okay, this is the general formula, but you must take in respect to this particular figure itself. Why? Because the H for the cylinder is not H anymore. What is it? It's 2R. So please replace your H by 2R so that you do not get confused. The only H you have is for the height of the cylinder. So now make H the subject of the formula. Agree? And hope that it looks like that one over there. Okay, I'm just going to simplify the expression. Now, make H the subject. Everything divided by pi r squared. You realize you can reduce to lowest term. Pi and pi will cancel. R cubed divided by r squared. You are just left with a power 1 for r. So in this case, lovely. Exactly the same as what is given in the question. Show. Now comes the difficult one. Show the total surface area of the container is that complicated function over there. Andrew, how to find total surface area of this figure here? For the cylinder. 2 pi RH, thank you. What else?
Plus pi r.
Okay, but what is this L? Can you help me?
The
Slanted length. But do we have the measurement of this slanted length? Then what must we do?
the square root of 2r plus r.
Okay. Take note, this slanted length, you must always make use of the Pythagoras theorem, so you can do your side working. This is L. L squared is equal to 2r bracket square plus r squared. Am I right? So after that, you need to make L the subject. Correct? Agree? Of course, you may want to simplify. You just square root 5r. So L is just square root of 5r. Now we are ready to plug it inside here. And remember, your H is this particular value. Replace your H by what you found in part 1. Replace your L by what Andrew just told us using Pythagoras theorem for the slanted length. And we have to be very cautious with our working now, because it must look like the form that is given in the question. Okay, I'm going to do term by term expansion inside the bracket. Okay, let's do our simplification. Over here, pi and pi can cancel. There's a r here, there's a r squared. Both divided by r. You're left with a r to the power of 1. Okay, we are done for the first term. Definitely it's just 120 over R. But you realize, the second bracket looks different. The two terms over here looks different from the one given in the question. What's the difference? There is a bracket in the question. How can we do that? Yes, Jermaine? Factorize. Take note, there is a common term pi r squared in both of these two terms. So plus, I take out the common term, pi r squared. Okay, let's write the root 5 first, minus 4 over 3. And then we have exactly the one given in the question. Please put show. Am I right to say that part 1 and part 2 is pretty tedious? So during exam, what happened? Some of you cannot even do this. Then, disregard the whole question? No. The bulk of the question comes in part 3. I say again, the bulk of the question comes in part 3. Even though you cannot do part 1, even though you cannot do part 2, doesn't matter. You just continue from part 3. Okay, this is what I want to emphasize. And they really give you a very good hint when they do this. Okay, why they want to do this? Because it's easier for you to do your differentiation later. Okay, let's take a look at part 3 now. Find the value of R for which A has a stationary value. So, Yuan Chen, what are we trying to find? A has a stationary value. A has a stationary value. Stationary value means? Yes, dA over dr, because it's already given in the question. But, so for stationary value, I'm going to write this down first until all of us are very comfortable with this. dA over dr is equal to 0. But do you think you want to differentiate this immediately? Fazana, can we differentiate immediately? What do you do first? How to simplify? 120. Thank you. The second one, do you need to simplify full term by term multiplication outside? Don't need. Leave it. Okay, everyone, can you please look here? Everyone, look at the expression over here. Even though there is a bracket, are there any variable inside? Can you realize that everything is a constant number? So if this is a number, are you concerned? No need, just treat this as a number. Pi is a number. So this whole term, just treat it as one singular term where this is a number. Okay, no need to go and take out the bracket anymore. So we can do our differentiation as per normal now. So now, what Yuan Chen told us, stationary value, dA dr is equal to 0. Of course, you need to find out what is your dA over dr. In this case, I'm going to do my differentiation. Does it look very complicated now? Do you realize? Remember, after we solve for stationary value equal to 0, you need to find this value of R, which is what they are looking for. Find the value of R. How to solve for R? We have done that last week. Something similar. Jiaqi, what should you do? Solve for R. Oh, very complicated. Take out R, but R to power negative 2 can take out. Maybe I help you first. Remember last week I said don't multiply by R squared throughout. What did I say? What was the approach? I said don't multiply throughout because you are telling yourself there's an additional answer, which we do not want that. What should we do instead? Yes, single fraction on each side. After that, then we can, what can we do? Cross multiply. Alright, now look on the whiteboard again. Everyone look here. I'm going to do very fast, but I don't want to do all the redundant steps. Yes, we can do our cross multiply. Can you see when you cross multiply, this will become R cubed? Do you want this constant number here? No. Don't want, right? But I need this R squared to join with R to get R cubed. If I don't want this constant, I divide 12 by this constant. Am I right? So what I have is this. All agree? Who cannot catch this step? Because I want to solve for R. I don't write too many redundant steps. So I cross multiply, R squared will become here. Divide everything 12 by this constant number here. This is my result. Now, everyone use your calculator. Press this answer. After that, press cube root. Okay, don't be ambitious, go and press cube root of this answer. But this one is really quite difficult to press. So press this answer first. After that, press cube root. Everyone must press, inclusive of Rachel. If you get a different answer from the rest, you deserve a slap. Yes, Jermaine, what's your answer so far? What's the answer? 31.15. 2.76. A few more, please, not a 58. So if we estimate, it will be 2.77 cm. Does everyone get this answer? If you did not get this answer, can you go and press the calculator again? Try it again. Press this value, press cube root. 1 dp is it? Okay, so please estimate 1 dp. This is only the first part of part 3. There are lots of parts. Okay, determine whether the stationary value is a maximum or minimum. Okay, very straightforward. The first derivative only allows you to find the stationary value. So now, if I want to find determine whether it's maximum or minimum, so what should we do next? Yes, Penny? Can do the box, no problem, can do the box. But you want to do the box? Okay, but let us take a look again. Can we say can do the box? I agree. Every question can do the box. But let us check. Is this easy to differentiate? Or maybe easy for me. You all think this is easy to differentiate? To me it's easy, so can I do the second derivative? Until very difficult, then we do the box. But if you are not comfortable with doing this, you can do the box. So if I perform my second derivative, I differentiate this value, I should get okay, of course this is not the end result. You need to simplify it. And what happens to this R? Are you going to leave it as just R? Start which value? 2.7658. Substitute inside here. And no need to find the value. You just need to determine whether it's positive or negative. Can you press the calculator again? Okay, I avoid drawing the box unless necessary. No one is pressing. What do? Positive or negative? You haven't pressed yet? I suspect it's positive. So this value is quite big, plus another positive value will still be positive. When R is equal to 2.8 here. So if the second derivative test allow us to say that it's positive, what can we conclude, Eugene? What should we conclude? What is minimum? Don't need to look at your question, look at the working. Yes. Okay, the numerator, the measurement implies A is minimum. Okay, the area is minimum. Are we done? What else is missing? You need to find the value of A, stationary value. But the stationary value is the minimum. So, minimum A. Plug in all the values inside A. Don't go use all this formula. Sometimes you get confused. You plug inside the wrong formula. Let's use the area formula. Where is it? It's here. Plug in your value of R. So, 120. This one die must use calculator and press. 2.7658 plus root 5 minus 4 over 3 pi. 2.7658 bracket square. Everyone, use your calculator and press this value now. And this question is worth 8 marks. Very lengthy. Kimberly, what's your answer? 65.1 estimated. You all get 65.1